My name's Colin Eberhardt. I'm from Scott Logic, and I'm going to be talking about WebAssembly and the death of JavaScript, which I'm sure is a really popular topic considering this is called Fin.js, but we'll give it a go, see what happens. I'm going to start off with a brief bit of history of the web, specifically talking about interactivity and the languages of the web. So most of you probably know that JavaScript, the language that we all know and mostly love, was invented by a guy called Brendan Eich in 1995, and he invented it in the space of 10 days. Which explains some of the quirks and some of the features that some of us like and some of us hate. Since then, a few other technologies have come along: ActiveX, Flash, Silverlight. Shout out if you've used one of these. Come on, Silverlight. Bit of love for Silverlight. Dart. It doesn't matter. All of them are dead. In 2018, JavaScript is still the only language of the web. It's a real shame for those of you that might have invested, a few million in a single dealer platform written in Silverlight, but these days it's still all JavaScript. And you might be thinking, well, that's fine, that's the way it is. Unfortunately, it's not fine. And a few things have changed in those past 20 years since JavaScript was invented. The first is just a personal observation. We write a lot of JavaScript now. JavaScript's in our build tools. JavaScript's part of our runtime. As an example, I started a new React app a few days ago. I installed Create React App, which is the standard tooling for React. 70,000 lines of JavaScript were downloaded from NPM onto my machine. That's a lot of JavaScript. So we're no longer writing just a little bit of JavaScript to make our web pages interactive. We're writing colossal sums of this stuff. Another observation: the way that we deliver JavaScript into the browser has changed in those 20-odd years. This is, roughly speaking, what it looks like when it reaches your browser. It's a highly compact, obfuscated version of the code that you wrote initially. So you write some code, and it goes through compilers, transpilers, minifiers, all sorts of things, and you end up with this garbage in the browser. Again, what's wrong with that? Does it matter? Well, yes, actually it does matter, and it matters quite a lot. This is a little timeline that roughly speaking shows what happens over time as some JavaScript is loaded into your browser and is compiled and executed. So roughly speaking, the first thing the browser has to do is parse all that garbage into an abstract syntax tree. It's then executed within an interpreter, and then the compiler kicks in, and you've got various levels of optimized compiler that starts executing your code faster and faster and faster. Sometimes the assumptions it makes about the code at runtime are false, so it has to re-optimize or de-optimize. Basically, it's doing some fantastically clever stuff to optimize the execution of your code. And obviously, you've got garbage collection as well. So the impact of this is that we're writing JavaScript code in things like TypeScript, in quite modern-feeling languages, but then we're compiling it to something which is quite simple, which is then parsed by the browser, compiled and executed. It's a highly inefficient way of doing things, but unfortunately that's the way that the web has evolved. And I love this particular quote. This was a quote from the WebAssembly team in their initial white paper. "The web has become the most ubiquitous application platform ever, and yet by historical accident, the only natively supported programming language for that platform is JavaScript. It was an accident. JavaScript was never designed to do what we do with it today," which is a problem. So that brings me on to WebAssembly. Now, I could tell you a lot about the low-level detail of WebAssembly, the type system, and all kinds of fun stuff like that. But again, I'll use a little quote to illustrate why it exists and what it's about. WebAssembly, or WASM, is a new portable size and load time efficient format suitable for compilation to the web. So WebAssembly is a compilation target for a wide range of languages that's designed to be portable, size, and load time efficient. So returning to the sort of execution timeline that we currently have, which currently means that users have to wait longer than they should for their application to become interactive. They have to wait for longer than they should for it to start executing rapidly. At the bottom, this is what happens with WebAssembly. Decode, optimize, execute. Much simpler, much more efficient, and much more appropriate for the kind of applications we're building at the moment. So let's have a look at a little bit more detail, just to give you a bit of a flavor of what WebAssembly actually looks like. So at the top of the slide here, you can see a WebAssembly module. So a key difference here is it's a binary format. That makes a lot more sense for delivery on the web. Now, to execute WebAssembly at the moment, you have to host it within a host environment, and the typical host at the moment is obviously JavaScript. So what you have to do is you have to load this binary module, you have to compile it, construct an instance, and then you can start executing. So this is actually a real example. It does a trivial math function of raise n to the power x. So this is a fully functional example. But this gives you a little bit of an idea of how it works. So WebAssembly isn't a high-level language that has access to your DOM and so on. It's a much more low-level language, which is a binary format which you can then execute and use from within your JavaScript. So what are people doing with this at the moment? What I'm going to do is just whiz through a few examples to give you a flavor of the kind of thing you might want to do with WebAssembly. So this is one of the very early success stories. PS PDF Kit. They're a company that have a product which is a PDF rendering engine. What they were able to do is take their existing C++ PDF rendering engine, they were able to compile it to WebAssembly and have it run within the client browser. Previously, their PDF rendering was all done server-side. So with WebAssembly, this new compilation target, they were able to do it entirely within the browser, which is really cool. This is actually something very recent. The recent Google I/O event, which I think was last week or the week before last, AutoCAD, who have a very popular, used by millions of people, a very popular computer-aided design package. What they've been able to do is take their code base, again, C++, and compile it to the web so that you've got the complete version of the AutoCAD software running within the browser. So again, they've taken a pre-existing C++ code base, so all the layout logic is then compiled into WebAssembly, and then the hosting part takes care of things like the canvas rendering. So again, it's a great success story. Something that we've done at Scott Logic, we've helped one of our clients, Active Financial, who provide streaming market data. They have their own proprietary protocol and their own mechanism for decoding that, which again was written in C++. Through WebAssembly, they were able to compile that to JavaScript and run it natively within the browser. And we helped them construct some of the tooling around that and help them construct a proper, rich API around that. And a final example, this one I particularly like, and the reason I like this one is because a lot of what you hear about WebAssembly is misinformation about performance. If you start looking around for performance tests, you'll see some inflated claims that WebAssembly runs 100 times faster than JavaScript, which generally speaking is false. JavaScript itself is actually quite fast these days because of all the time and technology that's gone into browsers. So I'll briefly explain this. There's a project called Source Maps, which is a very important part of most people's tool chains these days. If you recall the garbled mess of JavaScript I showed you at the beginning, Source Maps is a technology that maps that back to the original human-readable source. It's quite computationally intensive, and funnily enough, of course, it's written in JavaScript. So what the team behind it did was they rewrote it in Rust, compiled to WebAssembly, and what they measured here is a real human performance benchmark. They measured the time between setting a breakpoint in the browser and being able to read the source maps decoded output. And what you can see here is the results in Chrome, Firefox, and Safari. So the red cluster of dots is the JavaScript performance. The sort of, don't know what color that is, sort of bluish color is Rust compiled to WebAssembly. So two important things. One, it's actually quite a lot faster with a real benchmark. The other is the performance is much more repeatable. What you see here is a spread of data points for JavaScript, and that relates to the unpredictable runtime performance as it goes through just in time to various tiers of compilation. WebAssembly is much more predictable. So I think this is a great illustration of the performance gains that you can see by moving to WebAssembly. So finally, what I'm going to do is make a few predictions. Personally, I think WebAssembly is a very interesting technology. It's the first time in 25 years that we've actually got another runtime within the browser. It's not like a plugin, which is kind of bolted on the side. WebAssembly is supported by all the browsers. So for that reason alone, you really should be taking notice. So a few predictions. Throughout this year, I think we're going to see languages like Rust, C, C++ used in production for performance-critical algorithmic tasks. And the reason for that is those particular languages have features that make them a good candidate for compilation to WebAssembly at the moment. With some of these other languages, Java, C#, TypeScript, you're mostly going to see creative experiments. Without going into too much of the detail, Java, C#, these other languages require a garbage collector, and WebAssembly itself doesn't have a garbage collector yet. So that does hamper its usage as a compilation target for certain languages. Another prediction, threading will probably land in WebAssembly. The current version of WebAssembly is considered an MVP. Things like threading, host bindings, garbage collection, a whole load of things are on the roadmap. And just as we're seeing JavaScript iterate and progress very, very rapidly, I have a feeling we'll see the same thing with WebAssembly as well. We'll also start to see things like concepts that are being developed in the JavaScript world will start moving over into other languages. I'm sure you'll find React for Rust in the very near future. As we start looking a little bit further ahead, I have a feeling Java and C# will be considered production ready. You'll have people with backgrounds in other languages considering themselves first-class citizens within the web. Heavyweight productivity apps will move to the web. The funny thing is, I wrote this presentation about 2 months ago when I talked at FinJS New York, and it's quite funny to see AutoCAD announced last week. So my prediction for 2019 feels like it came true a year early. We'll also see another wave of mobile, desktop, server-side UI frameworks retargeting the web. I think we'll see a bit of a bandwagon, and I think we'll see write once, run everywhere all over again. Personally, I'm not convinced that's a good thing. Around this time, I think JavaScript's popularity will start to fall. And the main reason for JavaScript's popularity is because it has a monopoly on the most ubiquitous runtime. And as other languages start to get a look in, I think it makes sense that the popularity will fall. I also think that native Android apps will die out in favor of progressive web apps, which we're going to hear a little bit more about in one of the following talks, and WebAssembly. The App Store model is not a great mechanism for delivering applications to users. It's a bit like going back to the old version of the web, which was directory-based rather than search-based. It's not great for discoverability. Progressive web apps have allowed HTML5 applications to feel much more like first-class citizens. Couple that with WebAssembly, and you don't have any of the performance issues that you currently have with JavaScript. So I think the App Store may die out as well. Looking beyond, I have a feeling that Windows Store will drop support for non-web technologies altogether. I have a feeling that traditional desktop application runtimes are potentially a thing of the past. Maybe Mac will drop support for native applications altogether and will run entirely on web technologies using WebAssembly. There are various features of the WebAssembly runtime, its security and so on, which actually make it a pretty decent universal runtime. Finally, I think as WebAssembly has replaced JavaScript, there's one other technology that we're using day in, day out, which feels like a bit of a legacy, and that's the DOM. The DOM was designed for rendering of static content, and for most of us, the way we use it for constructing applications, it's a bit of a mismatch, it's a bit of a misfit. I have a feeling, in a few years' time, the DOM will fall as well. So there you go, that's WebAssembly and the death of JavaScript. You may or may not agree, but hopefully you've been entertained. Thank you very much.